Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. I am now checking the power factor of my refrigerator. Refrigerator is actually a motor load, and as you can see it, the power factor is actually 80%. Okay. If this power factor would have been unity, actually we decrease our current passing through our meter. But since right now I don't have a power factor capacitor installed on my refrigerator outlet, we cannot do anything about it but to accept that the power factor is 0.79. And this 0.79 is actually 80% is more than good enough. But if we could raise this one to 95% or unity by using a power factor capacitor, so much the better. So right now, the power factor is 0.79. That's a real thing. We cannot do anything about it. So if your house got so many motor loads and the power factor is not unity, actually you are consuming too much electricity because of the reactive power produced by the so many motor loads in your home. So I think it's a good thing if we could install a power factor capacitor in our homes to increase the overall power factor of our house to something like unity, so we could minimize our utility bill. And like what I said, the power factor here is 0.79. That's the real thing. Okay? Oh, that's my rep. Okay, that's the connection. Actually, I bring down my meter here for me to determine if the power factor of motor loads is actually not unity. And it is actually not unity. Like for this rate now, it is 80%. 80% is more than good enough, but if we could raise this one to 95% or simply unity by using a power factor capacitor in parallel with this, we could minimize the current consumption. Actually, the current consumption is not so much. I'll try to tackle it. The current consumption is 1.09 amperes. So actually, we could decrease this one if we could raise the power factor to unity. Okay, that's the power factor. Okay, so that's the real thing. Motor loads don't have a power factor of unity, and for this refrigerator, it is actually 80%. Okay. The current is not so much because it is now running in the so-called good mode. It's not on the starting mode, because on the starting mode the current is actually much higher, 4 times or 8 times. But since we are already in the so-called steady state, the current is not so much. Okay, the current is 1.11 amperes. At start, this should be around 4 amperes. But when the operation go to the so-called steady state, it will be 1.11. That's the true power consumption, 106 watts, 132 watts, 132 volt ampere for the apparent power. That's the frequency. And the last one will be the power factor. The power factor is 80%. That's the real thing. So in our houses, for as long as we have motor loads, our power factor is actually not unity, and actually we are consuming too much electricity. Good morning from Los Angeles. This is Professor David J. Tillersley.